Good morning, everyone. This is Henry from ASTEM Tutoring, once again attempting to serve as your wise old sensei. For today's lesson, I'd like to talk about an important topic in physics, the center of mass. So if you have a set of point masses, you can treat them for some purposes as if it's a single point at the center of mass, which would be somewhere in between the points. So in this system that I've drawn on the screen, along the x-axis, there are two masses, m1 and m2, at x-coordinates x1 and x2, respectively. To find the center of mass, the position, somewhere around here maybe, in between that could represent the whole system for certain calculations, we can use this formula. m1 x1 plus m2 x2 all over m1 plus m2. This will give us a value xcm somewhere in between x1 and x2 that represents the center of all these masses for purposes of further calculations, which we can talk about another day. Now, you can extend this to 3, 4, or as many point masses as you like. All you have to do is for each point mass, you multiply the mass of that point times its x-coordinate, sum up all those individual products, and then divide that sum by the sum of all the individual masses. If we want to write this with summation notation, we could use this. 1 over m, where capital M represents all the individual masses added together, times the summation across I of m sub I x sub I. So you could just extend this to as many points as you like. For those of you who want to think in terms of calculus, we can set this up as an integral. 1 over m times the integral of x dm. You take a distribution of mass, a continuous distribution of mass, integrate over the full mass at each small integral dm multiplied by the x-coordinate. That full integral times 1 over the total mass of the object would give you the x-coordinate of the center of mass for that object, assuming it's a predictable distribution that you could model with a function that dm that could be integrated. You could also extend this to 2 or 3 dimensions, a x center of mass, y center of mass, and z center of mass. You could find the x, y, and z coordinates of the center of mass for a distribution or a set of points. In later lessons, we will discuss examples of how to calculate the center of mass and how to use it for practical purposes. That concludes today's lesson. We've gone over the center of mass and the basic formula set up for how to calculate the center of mass. If you'd like to learn more, I am available for hire as a private tutor. The first 1-hour lesson is free for all new students. Try before you buy. You take no financial risk. The burden of proof is entirely on me to demonstrate outstanding value in helping you succeed. You can find my contact information in red at the top center of this whiteboard. And as a thank you for watching all the way to the end of today's lesson, when you contact me, please mention the code FREEBOOK. And at our first meeting, at our first lesson, I will give you a free copy of my book, Smart Suggestions for Student Success. This book is available on the Barnes & Noble website. I wrote this book in an effort to help students, and particularly high school students and college students, to succeed in school, in work, and in life. Thanks for watching. Have a good day.